Special Bulletin Erin. From a typical tropical system to the threat of a super hurricane. Good evening, and welcome to this special news bulletin on our channel. Today, the newsroom is busier than ever. Dozens of weather maps, satellite images, and live data feeds are updating in real time on the large screens behind me. Meteorologists from multiple countries are closely watching a swirling system over the Atlantic Ocean, the developing and strengthening Hurricane Erin. There's one detail that's both interesting and potentially confusing. Some international headlines this morning are still calling the system Erin. However, according to official meteorological agencies, the correct name is Erin, and this will be the main focus of monitoring not just for the next few days, but possibly for the entire week, should the scenario of strengthening into a major hurricane, Category 3 or higher, become reality. The 2025 Atlantic hurricane season has already seen several tropical waves. But Erin has particular features that have drawn special attention. If formed in the main development region, the birthplace of many historic major hurricanes, it is moving along a stable track with minimal wind shear, and most importantly, early forecasts largely agree that it will intensify rapidly as it moves into warmer waters. More than just a weather story, Erin is a test of international forecasting coordination, the preparedness of coastal communities, and, for all of us, a reminder of nature's power in motion. At present, Erin is still in the early stage of its life cycle. Satellite imagery shows an ill-defined center, with loose spiral bands and no fully developed convective core yet. Two main factors are holding back its potential strength: a surrounding layer of dry Saharan air acting like a moisture-absorbing cloak that suppresses convective cloud growth, and sea surface temperatures of only 26 to 28 degrees Celsius. Not yet high enough to provide abundant latent heat. However, this doesn't mean Erin will remain calm for long. History has shown many times that storms starting in less favorable conditions but later moving into warmer, moister waters can intensify rapidly. A classic example is Hurricane Irma in 2017. Which began modestly but exploded into a super hurricane when it encountered an ideal environment. The latest observations already show towering convective cloud tops developing near Erin's core, a sign that intensification could begin soon as it escapes the dry air zone. According to the U.S. National Hurricane Center, NHC, Erin currently has maximum sustained winds of about 45 miles per hour, a central pressure of 1,004 MB, and is moving west at 22 miles per hour. Forecasts indicate that around 2 a.m. local time, Erin will be upgraded to a fully classified tropical storm. By Friday, winds may reach around 160 kilometers per hour, Category 2. And by Sunday, it could surpass Category 3, officially becoming a major hurricane. One striking point: the time from reaching Category 1 to Category 3 is projected to be just 48 to 72 hours. This underscores the risk of rapid intensification, which significantly shortens the preparation window for affected areas. Territories such as Puerto Rico, Turks and Caicos, and parts of the Bahamas are being advised to review their emergency plans immediately. Among global forecast models, the European ECMWF model has drawn particular attention. It depicts Erin steadily strengthening as it moves northwest toward the northern side of Puerto Rico and near Turks and Caicos. Before nearing land, Erin could already be a Category 3 storm with sustained winds above 178 km per hour, a stable convective structure, dangerous winds, 4 to 6 meter waves, prolonged heavy rain, and flash flood risk in mountainous islands. Comparisons with Hurricane Maria, 2017, show the potential severity. Notably, the Euro model does not rule out Erin surpassing Category 3 to reach Category 4 or even 5, super hurricane status with devastating power. This scenario envisions Erin entering waters of 29 to 31 degrees Celsius. High humidity, and minimal upper-level wind shear, ideal conditions for explosive intensification. The projected path would steer between Bermuda and the U.S. East Coast, avoiding direct landfall but still producing large swells, dangerous rip currents, impacts to shipping and port operations, and coastal erosion. Meanwhile, the USGFS model suggests Erin could accelerate slightly and veer toward Bermuda before curving out to sea. This track would spare the Caribbean and U.S. mainland from direct impacts. However, experts caution against relying on any single model at this stage, as small changes in steering factors could shift the track by hundreds of kilometers. In addition to these main models, AI-driven forecasting systems and Germany's ICON model are also weighing in. Both AI and ICON indicate Erin could strengthen even more than some forecasts suggest, with ICON's extreme scenario projecting central pressure to drop to 928 MB, a level typical of Category 4 or 5 super hurricanes. Such data has meteorologists on alert, as models often underestimate the true strength of rapidly intensifying storms. The European Ensemble, which runs dozens of model variations, shows a wide spread of outcomes, from a path through the Caribbean and Bahamas with possible impact on Florida, to a recurvature out to sea. While most runs favor the storm staying offshore, there remains a small chance of approach toward the southeastern U.S. coast. Though unlikely, coastal communities are advised to stay vigilant over the next 72 hours. When model consensus on Erin's actual track should improve. As Erin continues northwestward, the environment ahead is changing rapidly. In just a matter of hours, the storm will exit the dry air zone and enter a region with high humidity. Sea surface temperatures between 29 to 31 degrees Celsius, and a broad upper-level high. This is the perfect recipe for rapid intensification, the most concerning scenario for any forecaster. Rapid intensification isn't just a steady strengthening, it's a sharp leap in intensity over a short period, with winds increasing by tens of kilometers per hour in just 24 hours. This phenomenon makes forecasting much harder, as even small timing errors in the models can dramatically alter outcomes. Hurricanes Michael, 2018, and Patricia, 2015, have shown the catastrophic potential when such intensification occurs close to landfall. Upper-level steering currents are also playing a crucial role. The subtropical high north of Erin appears weaker than expected, and the upper-level flow is not exerting strong directional control. This could allow Erin to find its own path, gradually curving north. However, if a trough from North America dips southward more quickly, it could alter the track, bringing the storm closer to the U.S. East Coast. Meanwhile, across the U.S., many states are experiencing severe thunderstorms with flash flood warnings in some areas. Extreme heat persists over Texas and nearby regions, with heat indices potentially exceeding 43 degrees Celsius. On the East Coast, some coastal zones are under rip current advisories due to indirect effects from the distant tropical system, Erin's expanding outer circulation. To close today's bulletin, we want to leave you with a note of encouragement. Life can often resemble the journey of a storm across the ocean, seemingly calm at times, but with conditions that can quickly turn turbulent. In both quiet days and moments of trial, the most important thing is not just material preparation, but also holding steady within, finding an anchor that keeps you from being swept away. That anchor may be faith, family, or simply your own resolve. And just as coastal communities are preparing to face Erin, each of us can face the storms of our lives with vigilance, patience, and gratitude.